This week, reversing the carbon clock. New technology could turn back time on CO2 emissions. But what exactly is carbon capture, and how does it work?
Instead of letting it go in the atmosphere, we intercept it and capture it from the smokestacks, or sometimes we change the process to minimize what's coming out.
Syngas, biochar, and air vodka. We speak to the startups taking carbon capture tech mainstream.
In 2050, I'm convinced that all Fortune 500 companies will be using carbon removal in order to achieve their net zero targets.
And scaling up the solution. As energy prices soar across the globe, when does carbon capture become cost effective?
No one is planning to just spend a lot of money on the investment that it would take to do carbon capture at scale.
From Bloomberg's world headquarters in New York, I'm Kaylee Lines, and this is Bloomberg Green. Last week, we spoke about the IPCC report's findings of irreversible climate change. But what if we could reverse the root cause of global warming? In this edition of Bloomberg Green, we delve into the idea that may just make that possible: carbon capture. Carbon dioxide pollution from humans, mostly burning fossil fuels and clearing forests, is the main driver of global warming. CO2 levels are 50% higher than pre-industrial levels, and the last time they were this high, some 3 million years ago, the world was a very different place. But technologies that capture and store carbon from the atmosphere could be a potential solution. So coming up, we'll speak with the CEOs of 4 startups, each with their own approach to capturing, storing, and using excess carbon. Then we'll appraise the use cases of these techniques and at what cost they become viable. But first, an explanation. What exactly is carbon capture? And what are some of the different processes by which it can be accomplished? Our reporter Ryan Hesketh explains.
Since the Industrial Revolution, humanity has treated the atmosphere as one giant carbon dump. But our carelessness is coming back to bite. Every day we burn more fossil fuels, pumping billions of tons of greenhouse gases into our already saturated air. Wouldn't it be nice if, instead of releasing this waste, we could catch it, store it, and maybe even use it?
Instead of letting it go in the atmosphere, we intercept it and capture it from the smokestacks, or sometimes we change the process to minimize what's coming out. And then once we capture that CO2, we have to do something with it. A lot of times we'll transport it in a pipe and store it in deep geologic formations. So we take fossil fuels out of the ground, burn them, and then put the CO2 back into the ground.
Howard is an MIT professor who's been working on carbon capture and storage, CCS for short, for more than 20 years. So how do you take a waste substance and capture it, keeping it out of our atmosphere?
The one that's used most is called chemical scrubbing, where you take the exhaust gas from these processes, when you put it through a small chemical plant where you take a chemical and you contact it with the flue gas, it will remove the CO2 from that gas. Now you can put the gas back up the smokestack that contains very little CO2. Then you take the chemical that absorbed the CO2, you regenerate it, so it releases the CO2, so you have CO2 in a pretty pure form.
CCS isn't limited to just removing carbon from the fuel we burn now. It can also draw down historic emissions. Techniques include the processes Howard mentioned, but also planting trees and changing agricultural practices. No one technology will reign supreme, but taken together, they could have a significant impact.
The question it really is, how big are they, in terms of scalability, and how much land can you use for that? And also, cost of most negative emissions is pretty expensive. The other thing about negative emissions is, say you plant a forest, take CO2 out of the air and store it in the forest, how permanent is that? Will that forest be maintained for the decades and centuries you need to do it?
With a few technologies and a lot more trees, we could capture a significant portion of the carbon we emit, as well as begin clawing back our historic emissions. But once we have trillions of tons of captured carbon, what do we do with it?
Right now, the main thing is transport it. The most efficient way to transport it with significant quantities is in a pipeline. Certain places are looking at ship transport, such as in the North Sea area of Europe. They have a project looking at transporting it by ship and then putting it in geologic formations.
There is space to bury much of the world's emissions, but is there a better way? Can this carbon become a useful resource?
Even though there's carbon and carbon dioxide that can go into, say, different types of materials, there's not the energy. And to put the energy back into it, if you're going to use, say, fossil fuels, then you're just going to create more CO2. If you have a lot of renewable energy do it, you can maybe do that.
CCS is now widely recognized as one of humanity's tools in the fight against climate change. It's being supported by governments across the world, and big industry players like Shell and TotalEnergies are funding projects. But its impacts at present are limited due to the massive amount of carbon already stored in our atmosphere and the billions of tons we continue to release every year. Any investment now is a risk, but the potential payoff could be huge.
Brian Hesketh there, running us through some of the basics of carbon capture. So now let's get to the businesses trying to make it into a reality. Climeworks is a pioneer in direct carbon capture, sucking CO2 from the air and storing it underground. Its facility in Iceland, Orca, is the largest of its kind and captures 4,000 tons of carbon dioxide a year. That may only be equivalent to the annual emissions of 250 U.S. residents, but it's a powerful proof of concept. I spoke to the CEO of Climeworks, Christoph Giebold, about how that technology works.
Direct air capture is essentially building machines, very large machines that are sucking in air and taking the CO2 out of the air and let all the other components go through the machine and then provide the CO2 for usage or underground storage.
So what exactly happens to that CO2 once it's captured? What does it become?
The focus of Climeworks is to take the CO2 that we're capturing from the air and subsequently provide it for underground storage. We're currently doing that in Iceland with a facility that we're calling Orca, where we do have a partnership with another company that is called Carboculture, who are responsible to store the CO2 in the ground. And once the CO2 is in the ground in Iceland, the CO2 is mineralized, or in very simple words, we are turning the CO2 into stone in the underground.
As we look toward the future and a push not just on the part of businesses, but governments around the world to reach net zero, is there still going to be adequate demand for the kind of product and service you are offering for carbon removal if we have a world that is more focused on cleaner energy and a lower carbon footprint?
Both go, or both have to go hand in hand. Like today, I always like to say, as of 2022, you're not allowed to use the word "or" when it comes to climate change mitigation. You're only allowed to use the word "and." You have to reduce and you have to remove. You have to do both. A net zero target entails both, like reduction as well as removal. For example, there's the very renowned and prominent Science-Based Target Initiative, where they say that roughly 90 to 95% of the job can be done with reduction and 5 to 10% can be done with carbon removal. Now, as to your question, will there be sufficient demand? We're currently emitting 40 to 50 gigatons of CO2 annually, right? So we have to bring those 40 to 50 gigatons to zero. And thereafter, we have to add another 10 to 15 gigatons of negative emissions. And like looking at those numbers and multiplying them with the 5 or 10% that are claimed for removal will yield a tremendous market. Like the market for that in 30 years down the road is equivalent to the size of today's oil and gas operations. So some people title what we are doing will be in 30 years from now, oil and gas in reverse.
Christoph Giebold there, the CEO of Climeworks. So up next, we'll hear from the CEOs of Dimensional Energy and the Air Company, which are both turning carbon into something useful, but in drastically different ways. This is Bloomberg Green.
from Bloomberg's global headquarters in New York, I'm Jennifer Zabasaja, and here is all the climate news you need to know this week. First off, the UK government is considering changes that allow for new permits for oil and gas in the North Sea. An exemption could be made for energy security as Europe is urgently looking for alternatives to Russian oil. As well as expanding domestic oil and gas production, the UK government is looking to accelerate alternate energy, including onshore wind power and nuclear power. Also, Rapa Nui, also known as Easter Island, is at risk from climate change. The 14-mile-long island that's famous for its stone statues is dealing with a lack of rain as temperatures heat up and rising sea levels in the Pacific. The people living on the remote Polynesian island contribute basically nothing to carbon emissions but face an uncertain future. And finally, President Obama's next act in retirement will be acting as a national parks champion on Netflix. He will narrate a nature documentary for the streamer featuring the world's wild spaces. The Obama administration put more than 550 million acres of land and water under permanent protection during his presidency. And that is your Green Brief. Kaylee, definitely something that we saw former President Obama do during his time in office, taking it to the streaming world right now and expanding his audience a little bit more.
Really just continuing that work and doing so in almost David Attenborough style. And of course, we've seen other big figures signing their own deals with Netflix, the likes of Prince Harry and Meghan Markle also doing this kind of work, but clearly the former president focused on the climate. Thank you so much to Jennifer Zabazaja with this week's Green Brief. So let's take a look at another question. How can carbon capture lower the emissions of the airline industry? A startup called Dimensional Energy plans to use sunlight and captured CO2 to power planes. It's a greener alternative to jet fuel and an innovative way to reduce emissions in a sector responsible for 2% of annual CO2 production. Our reporter Sarah Rappaport has more on this startup's sky-high ambitions.
Dimensional Energy is a small startup with big ambitions.
Our company is transforming carbon dioxide into sustainable aviation fuels.
That's CEO Jason Selfie. His company's mission is to transform the world's most energy-intensive industries to zero emissions by 2050.
We started the company in 2016 with a focus on utilization of carbon dioxide. My co-founders and I, were discussing some of the gaps in the challenge to mitigating climate change.
But how does it work exactly? What it does at a basic level is takes carbon dioxide and water and transforms them.
That can be captured from the air or from a point source. We take those two materials and we push them through our reactor, which is comprised of catalysts and a really interesting form of a reactor. Undergoes a chemical process that transforms those two molecules into a synthetic fuel.
By 2025, the company hopes to have a platform that can produce fuel for less than $1 per gallon. If successful, that means the carbon-heavy aviation business can adopt carbon-neutral fuels, but they're not there yet.
We're a rather new company, so we're starting out with we have a 5-gallon per day demonstration in Tucson, Arizona right now that we're getting ready to commission. And then we're looking at a several barrel per day facility over the next year that we're in talks with strategic partners on. And our goal is to have a 100 barrel per day demonstration facility in 2025.
It'd be a big change for an emissions-heavy industry if carbon capture proves to be reliable and cost-effective.
That was our Sarah Rappaport on Dimensional Energy. So let's go from airplanes to air vodka. Air Company's chief product was called one of Time Magazine's best inventions of 2020. Simply put, they are taking CO2 out of the air and turning it into alcohol for human consumption. During the pandemic, they also started to produce hand sanitizer. So I spoke to the CEO, Gregory Constantin, about why it was so important to use carbon capture in making consumer products.
We take carbon dioxide, which is the most abundant greenhouse gas on planet Earth causing climate change, and we turn it into carbon negative alcohols and fuels. So, we take the CO2 out of the air before it's emitted to the atmosphere and turn it into the products that you see today.
Well, and among those products, perfume, hand sanitizer, vodka, why focus on consumer goods?
Yeah, we think that consumer goods are one of the best educational tools to show the world and to show people that you can use technology and creativity, and when you blend those two things together, you can create real impact. And by creating consumer products that people can touch and hold and taste and feel, it becomes a reality, and the technology behind it becomes a reality to people. So they're a great educational tool for people to show the world what's possible with technology like this.
And where do you expand in the future, maybe beyond consumer goods?
Yeah, so our company is focused on consumer goods in the short term, on a pathway towards, true scale and real scale towards kind of industrial applications of things such as the fuels that I mentioned as well. So as we scale up our technology and it becomes more readily available, we'll be working on applications for things like sustainable aviation fuel, where you can really create true impact at scale.
Well, and you say on your website, if your technology was scaled across all possible verticals, you would emit a great amount of global carbon dioxide emissions. Can you just talk to me more about the numbers and metrics surrounding that?
Yeah, we'd actually be able to emit or remove or stop or hinder over 10% of annual CO2 emissions globally if our technology was applied to every industry vertical that it could be, and that's for one single technology. So you're talking about billions and billions of tons of CO2 utilized on an annual basis. Now, for us, we hope that we can be a part of the solve of the challenge, and the goal needs to be a massive goal like that, and you need to have a big challenge like that ahead of you, so that you can strive towards that and you can inspire others to strive towards things like that as well.
Coming up, changing the culture when it comes to CO2 emissions, how one Helsinki startup has hit on a new solution for carbon capture, and we'll dive into just how cost-effective all of these technologies are next. This is Bloomberg Green. From Bloomberg's World Headquarters in New York, I'm Kaylee Lyons, and this is Bloomberg Green. Now let's get to our final startup. Henrietta Moon leads Carboculture, a Helsinki-based company focusing on scaling what it calls a brand new carbon capture technology, drawing direct inspiration from the natural world. We spoke to her about what makes her business different.
Most life on Earth is carbon, and it's our fourth most abundant element, so it's not bad per se. We just have it in the wrong place, in too much scale. So we need to think of the most elegant way to actually bring down that carbon from the atmosphere and put it to use somewhere where we can use it better.
This challenge is at the core of Carboculture's mission. The Helsinki-based startup is focused on solving the Earth's carbon problem while offering a viable business model, one that didn't even exist at the beginning of her career.
I ended up in this crazy program that was a 3-month intense program at NASA Ames in California, and that's where I met my co-founder Chris Carstens. Back then, there was no price on carbon. Emission trading was at maybe €5 a ton, and nobody was really interested in pursuing that as a business model. We got started properly in 2017. Today, the carbon market is trading at over 10 times that, so times have changed. Every year, nature draws down carbon in the form of photosynthesis into all our biomass, trees and plantations and crops and everything you see. But naturally, when that biomass, like the trees, die, they decompose and re-enter the atmosphere again. And that's the natural carbon cycle. At Carboculture, we were trying to figure out what is the most elegant way to actually draw down some of this carbon. And instead of trying to invent machines to take out parts per million from the atmosphere, we decided that millions of years of nature already knows how to do it. So if you see a forest today, and in 500 years, it'll essentially be the same size. It's not going to 10x its carbon removal capacity or grow 10 times larger. So we have these solar-powered allies who use photosynthesis and turn this carbon from the atmosphere into biomass. And we take that biomass, such as nut shells or peach pits or tree waste, and we put it into our patented reactor, and we rapidly take it to ultra-high heat where it carbonizes. It doesn't decompose, it's not eaten by microbes or anything, and we can store it safely in the soil.
Their first facility resides in California, which operates as a proof of concept to demonstrate the process.
Basically, we put biomass in there and we put them inside. We take them to an ultra-high temperature, about 1,000 degrees Celsius for a split second. And in that time, the biomass carbonizes. So it turns into a charcoal-like form. You can mix it into compost or put it in the soil or use it for water filtration or just bury it in the ground in an old mine shaft or something.
Now that they've mastered the concept, it's really just a matter of scaling it up by a factor of 1 million or so.
If we put 1 million of these systems around the world, we can actually use part of the energy in the biomass itself to power these systems. And in this way, we're helping the green transition of the grid instead of hindering it. This next scale up at scale would remove about 13,000 tons of carbon dioxide annually. So make a few thousand tons of biocarbon, and that's a big step for us.
Though Carboculture has recently raised $6.2 million in seed financing, it will take a lot more funding to get Carboculture's vision to scale. This Herculean effort will require investments from both public and private sectors. And now that carbon capture programs like this are beginning to get traction, Henrietta welcomes the competition.
If we look at the big picture, we have a North Star mission of a gigaton of removal, which is 1 billion tons. And it's a real insanity target. It's definitely not easy. It's light years away from where we are today. But for us, it means that we also need to get to that kind of a scale. And there's probably going to be 10 to 100 companies like us in maybe a decade from now that will be trying to get to that gargantuan scale that is needed.
A look at Carboculture there. Now, let's dig into these technologies with Bloomberg's climate change and renewables reporter Will Mathis to discuss carbon capture and carbon pricing. So, Will, first, let's start out with what's the most commercially viable carbon capture technology out there at the moment?
Well, I mean, probably none of them are commercially viable. You know, no one is planning to just spend a lot of money on the investment that it would take to do carbon capture at scale. But the ones that are being pursued and supported by European governments with billions of dollars of subsidies are the kind of traditional carbon capture, which basically just traps all the emissions from existing factories or plants and takes all those emissions and just pipes them underground to be stored, in this case, you know, where they're being pursued at scale under the North Sea in reservoirs that, you know, previously held fossil fuels.
If it's not commercial viability, then what is the use case of carbon capture technology right now?
Well, there are certain industrial processes that just produce emissions. You know, if you make cement, there's really no way to produce cement, which is one of the most important building materials in the world, without producing CO2 emissions. So if it's your government policy to eliminate those emissions, then there's really no choice but to trap the emissions with carbon capture. And so and if you want to do it even quicker, then maybe you can't wait for technologies in other sectors that could potentially decarbonize. So if you want to cut emissions really quickly, you can use these capture technologies to trap all the gases and just keep them out of the atmosphere.
All right, Will Mathis, Bloomberg climate change and renewable energy reporter, thank you so much for joining us. So carbon capture is not a silver bullet to fix climate change, but with a variety of solutions, it could become a key tool in restricting global warming and meeting the world's net zero targets. That wraps it up for this week's episode, but you can keep the conversation going by following us on YouTube, Instagram, and Twitter @Climate. From Bloomberg's global headquarters in New York, I'm Kaylee Lines, and this is Bloomberg Green.